So welcome everyone. Welcome to our second part of the series on SPDM. My name is Melissa, and together with Matthijs, I will be our host for today. And we have Keith presenting from where we left off last time on data management, this time continuing with process management for simulation and CAE. So if there are any questions during this session, you can leave them in the Q&A, or you can always contact us on via the email addresses you see on the screen. And with that, I'd like to hand it over to Keith so we can get started with more SPDM.
Okay, so hello everybody. My name is Keith Dunlop. I work out of the UK as part of our European engineering lifecycle management team. And as Melissa's already said, this is the section following on from the focus on data management a couple of weeks ago to look at a little bit more of an in-depth view of process management. So for just clarity of where we are with this, if we talk about SPDM, the broader domain as being simulation, process, and data management, the focus today is very much on the process side. If you want to refer back to the data content, there's a recording available which you can go back and review that at any stage, and it might fill in some of the gaps, which I'll gloss over very quickly today in terms of the data management side. So just to reiterate what we're talking about, within MSC, the product that we're referring to here is SimManager. We have a rich pedigree of about 20 years worth of production experience of the use of SimManager in various disciplines and various industries. But what we have really now is very much a configurable product which is able to be deployed quite quickly at various customers' implementations. So you should be able to get up and running with SimManager quite quickly and see some benefit, but then potentially extend it to be more tailored to specific requirements, customer by customer. And hopefully today sparks a few ideas of ways in which that focus might actually happen. Okay, so for today, the focus, as I say, really very much on process management. Process within SimManager is quite a broad-ranging discussion. Different processes are important to different people, and out of everything that's available in SimManager, there's a wide, sort of rich list of capabilities that we could implement and talk about in relation to processes. But a list of 10, as you see them here, is quite a lot for a short session today. So we'll try and cut it down to sort of about 7 main topics, which I'll touch on in different levels of detail. But if there's any additional detail you need, please feel free to come back, and we can fill in the gaps at some point moving on. So probably worth going through a quick recap of what we talked about a couple of weeks ago, just on the data side. This maybe gives a bit of an indication of what we talked about for those who weren't on that session as well. So that session focused very much on the data management side, the structure of information within SimManager. But basically, we were focusing on the idea of saying, well, initially an introduction to the interface. This is a web-based application for most implementations. What you'll see demonstrated today is a combination of a few different interfaces, but from the previous view, everything was really driven from a web browser as being the, if you like, the focal point or the entry point for most users. So no software required to be installed in every client machine. It's really reliant on SimManager acting as a server to host all of the data that is generated in the simulation process, and then provide that out to the end users as a web application environment. The interface itself is a configurable UI. The landing page you see here, users can decide what they want to see whenever they log in with the appropriate access control that they've got related to their login. You can then have a display of information where you've got quite a rich capability to allow you to present a lot of information, but also enrich that with additional images or extractions of the data in the individual files. But the idea being that models that you create or models that other people create should be available to a broader engineering community. So data is not just the domain of a user, but is also available to other engineers in a product. So you want to be able to share and reuse that where possible. In terms of presentation, there's lots of options for reconfiguring views to suit data presentation. In this case, we're looking at what we call navigation trees, so sort of hierarchical views of data, where you can have multiple hierarchical views presenting data, whether it's geometry, input decks, loads, results, models, geometry information, whatever's required. You can build, and users can configure their own navigation trees to be able to present information in the way that's most suited and relevant to the end user community. So there's a very wide range of options available to any implementation. And in the last series, we also showed examples of the ability to be able to generate models, generate key result values as curves, images, movies, and then combine them together either into reports or into overlays of comparisons of individual responses for certain analyses, or indeed do side-by-side comparisons of two different assemblies where you can very easily see what has changed between assembly 1 and assembly 2. So there's a whole range of options that you've got available in there. And then finally, on the execution side, a key part of what we want to try and manage within SimManager is not only the data and the processes which link to tools and applications themselves, but once an analysis is done, we provide traceability and auditability on how that data was generated and what the relationships are between any data item in the database and the constituents from which it was built. And if necessary, we can also include a process view to show the applications that were used between each of these data items that you see here. So the idea is that we provide an unambiguous view and an audit trail of everything created in the database. And this is done automatically whenever you execute processes through SimManager as well. Okay, so that's kind of a very quick overview on what we talked about last time. What I want to do now is to just recap on one of the processes that we talked about last time, which was an import and simulate process, where we started off with a run-ready analysis deck and just launched that into SimManager to be able to run an analysis. So just replaying that, the series of steps the user went through, the navigation tree into the project of interest for them, where they wanted to collect this individual piece of analysis data. And then it's just a matter of running through the import and simulate process, where the last session I browsed through and got a file from my local desktop. Here we're getting data from a network drive. You simply select the run ready analysis deck, and now we can submit the job, which chains together the execution of the analysis itself. So in this case, running Nastran, but it's open to run any application at all. It doesn't have to be an MSC specific solver. So SimManager is a very open environment that allows you to be able to integrate any application. So we've got the analysis run. This is the view of the input deck that has been loaded as part of that process. We automatically capture the results, and then from the automated post-processing that's been configured in this analysis scenario, we automatically capture the key results that have been generated, and key results might be images, curves, movies, numerical values, whatever is required in this instance. And then also from those key results, we then chain together a reporting template, and the report generation can be automatically executed once the key results are available. And in this instance, you can see the presentation of the data either as a collection of images or histograms or whatever built from the numerical values from each of those. And this allows you to very easily do side-by-side comparisons of a couple of different variants, which we did last time. So just to summarize on that and then talk a little bit about some of the detail. Stage number 1 from a user perspective is just to launch the import and simulate process. This now starts a chain of analyses where the input deck is managed in SimManager. It's connected through to the HPC environment, and of course the configuration of SimManager in the background should take away all of the overhead from the user in terms of moving files from one system to another, logging into the HPC environment, and then launching the analysis job with the appropriate commands and everything else. All of that is handled by SimManager, where the user can select various options in the user interface that you want to expose to them. But the idea being that we should take away all of the, if you like, the administrative aspects of doing that job execution. Whenever the jobs run, the result is automatically returned back into SimManager, where we can then launch some post-processing. In my example, I was running Patran and Batch, but maybe you're running, I don't know, Hypermesh or Hyperview or Anso, or maybe you're running some in-house Perl scripts or Python scripts to be able to extract data out of those results. But from that post-processing activity, we generate a set of key results, and then those key results are combined together into a report. So that's, if you like, the analysis chain that we have executed in here, where everything is run automatically from the only user input being the red box, being the import and simulate process. Now, once the job is actually run and finished, of course, we're finished with the HPC and the batch execution environment, but there's maybe some supplementary activity that is desirable, and that can be run as an enrichment process. So we can configure additional enrichment activities within SimManager that allow you to process any model or any data item in SimManager to be able to either extract additional information from it. So in the example you saw in the movie, we generated that three-dimensional view on the top left, which was generated using a piece of partner software that we have from VColab. So it generates a lightweight representation of the model and allows you to be able to visualize it in 3D in the web page as well. But that enrichment might be using different applications as well. So maybe you've got some data that you want to reformat into another format of file and save as a different model as well. So you can use enrichment to execute that kind of process automatically too. And that's something which is very powerful and certainly is very useful if you're running environments where you have multiple disciplines working together in a particular project. Okay, so where do we move on from that import and simulate process? So the key part here really is to take what I have in the bottom left view as our import and simulate process, where you're starting from this red box on the import of that file. And what I want to do is to say, okay, well, whilst the import and simulate is a great first step and is actually a typical first step for a lot of implementations of SimManager, we now want to grow the implementation. And the next phase often is to have an assembly phase on top of that. So rather than just importing a run-ready analysis deck, what we can do is to take a series of components that exist in SimManager already, maybe generated by different people, and these would represent different parts of the substructure of a model. So they might be, in an aircraft example, it might be individual wing components, spars, ribs, skins, stringers, etc., all generated individually by different users. Similarly, those models might be materials, or they might be loads, okay? Or there could be a whole series of different components that need to be assembled together into a run-ready analysis deck. But what we want to do is to have an assembly process managed within SimManager. And this is the view on the right-hand side, which we'll then see. So what we effectively have is a matrix view, where every row is a component that needs to be assembled together, each of which is managed independently in SimManager, maybe generated by different people over a different series of time. And then each column is representative of an analysis that needs to be done. Okay, so this might be individual load cases that you want to consider, or it may indeed be different types of analysis as well. So you may have a linear static analysis, a normal modes, and a dynamics analysis that you want to be able to execute simultaneously from one assembly environment. So this is really what we're focusing on with SimManager, is to have the logic built into this assembly procedure, but present a very simple interface to the end users, so it's very easy for them to see what's actually happening. So in this case, we're starting off with an empty assembly. So we've got the item and variant created already. And now in the view you see of this matrix, each row is an individual model that can be selected from pre-existing models in the SimManager database. Or if you've got something available on disk, you can upload it at this point as well. With each of these, you can see here we've got 3 different types of analysis that we're going to do. So a SOL 101, 103, and a 109. So Nastran specific solution sequences, but these can be extended out to other solvers as well. And the key difference between these is not only the solution sequence that's going to be run, but also the type of post-processing that will be executed. The other nice thing we have here is the ability to submit all of these analyses simultaneously. So rather than assembling one at a time and then submitting each one in turn, we can say, well, from this one user interface, we can pick the appropriate submodels, pick the appropriate loads for each of those analyses based on the templates in there, and submit all simultaneously. What you see now is if you like, the view of the process trail on the left-hand side. So as the analysis is running, you see that tree building over time to be able to show the status of the analysis execution for each of the solutions that are being run. But as also a part of the process, you can also then review and interrogate the input deck, as we saw previously, or the result as we have it here, to be able to be sure that that assembly has been done appropriately and everything fits in the right place and it visually looks correct, rather than having to open up a preprocessor and go and load that model in there. And then, as you would expect, and we covered previously, we automatically capture the results of each of those analyses, and then from the analysis themselves, we can then recover all of the key results, whether they're images or curves and everything else associated with that. And all of that is visible in the audit trail. So that's one key aspect of process that I wanted to bring out today, which was that assembly activity. And you'll see another example of that later on with a slightly more complex example. But what I want to show now is an example of running exactly the same model, so exactly the same sort of pipe assembly model, very simple case, but using a very different interface. So in this case, what we've done is to build up an example using the REST API. So this is an open API that we have with SimManager, where we wanted to build a slightly different environment where we focused on all of the analysis being done from a preprocessor. So rather than it being run from a web UI where everything has been created and imported previously, what we're going to do is to run it from Apex as the interface. Okay, and this could be implemented in any other preprocessor as well, but in our case, we've got Apex as a tool within our suite, so we had the opportunity to be able to do this customization. So there are two stages to this that I wanted to show. So two slightly different implementations of if you like, a custom application using the REST API to provide an interface with SimManager. The first one is building packages of data for import into SimManager, and in this case, focusing on CAD data. So let's say you've got a CAD assembly on your local disk. It's a collection of CAD parts and CAD products that you want to import into SimManager. Now, we can either do that by importing individual file itself, but for something which has got 3 or 4 parts, that's fine. Once you get to something which has got 100 components in it, that's really an unwieldy process. So we want to be able to automate the process of building up the assembly information about that CAD part and CAD product, and then from that, build an import package which we can then bring into SimManager. Okay, so opening up a specific application on my desktop, I can now select the option to say, okay, let's go and pick the CAD part or CAD product, and I'm basing it on CATIA here as one example because that's what I have, but it could be any CAD assembly. I'm going to select a temporary area in which I want to work for this particular example. And now we're looking at the SimManager content. So now we're browsing the folder structure or project structure in SimManager, browsing the phases that are listed in SimManager, and then we can build a package and then launch the import of that data from my desktop, pushing that CAD assembly into SimManager. So it now exists as a collection of CAD files or a CAD assembly within a specific project in SimManager. So that's our repository from which we're going to start our base model. So now we can go through the next phases, which are the pre-processing in Apex, where we want to, from the Apex UI, browse the content of the SimManager project, select the assembly that we've just imported, import that into Apex from SimManager, and then we're going to run a process to batch mesh it and prepare for analysis. Okay, and then the final stage of it, once we've done that sort of mesh or model creation, is then submit the job. But rather than submitting the job and doing the analysis locally on my desktop, what I want to do is to import both the Apex database and also trigger an analysis from SimManager. So the job will actually be run from SimManager, connecting through to the HPC backend, and then we go through the previous process we had where we're collecting the results. So custom UI, we've got a button up here on the right saying retrieve from SimManager. I log in as my user, and then that allows me to now connect through to the SimManager database where I can browse the project structure. This is the project structure in SimManager, but browsing it from the Apex UI. I can select my assembly and then load that into Apex. So this is now recovering the CAD assemblies into my Apex interface. And from here, I can now go through a process of doing whatever is required to build this model. So as part of this process, we've built a little script to go and automatically do the meshing, apply the loads and boundary conditions, and set everything up in this. So it's showing off a little bit of the Python scripting capability in Apex as well. And then the final stage is let's now push this data into SimManager, where I can select the project in SimManager into which it wants to go. I can select the scenarios for the type of analyses that should be done. So in this case, we're going to do a SOL 101 and a SOL 103. And we're going to create a new item invariant, which you'll remember hopefully from the previous session, for the Apex model. And then we're going to push that into SimManager and also start the process of analyses. So it's not just an import export of the data, it's also from the REST API launching a process within SimManager as well. So we've got the capability within the REST API to be able to manage a lot of activity where you can push data, pull data to and from the SimManager database, but we've also got the ability to actually launch processes as well. And that can even be extended through to quite a wide-ranging set of actions and capabilities, which might even be extending through to creating new users and all sorts of other aspects as well. So in this instance, the audit trail that has just been switched from was looking at the audit trail from a specific key result value. What we're doing now is to say, well, actually, let's redraw the pedigree view, but starting from the Apex database itself. So this is our Apex model, which we've stored as an analysis geometry model, which this is our bolted assembly database that we have for Apex. It has been built from a design module, which is our CAT product, which itself has a relationship back to the 3 CAT parts that you have in the system. And we know that this has been used to build 2 input decks, one for durability, one for NVH. And then those input decks have been used to generate 2 sets of results with a whole series of key results coming from that. And then we've got some comparison reports. So you can see that from this Apex session, we're able to launch all of this downstream activity, which in this case is an analysis, but it could be any other process that you have registered as an application or as a sim process within SimManager. Okay, that was showing an example using Apex as the preprocessor, and it had quite a sort of tightly scripted series of actions that were run within Apex. But it's important to know that, or it's important to realize that there are more than one way, or there's more than one way of using a preprocessor or managing models or building models in an analysis domain. And in that sort of context, we have to, within SimManager, accommodate that very clearly. So whilst there is an ability to be able to manage batch processing and all sorts of other aspects like that, and we can support the execution of that batch processing activity, there's also a requirement potentially to do something which is much more manual, to do manual file imports and sort of drag and drop of files and folders. And all of that was covered in the previous session. So I'll not dwell on that and recover that. But if you want to go back and see how we do that and how we manage that, you can refer back to the previous session. But within SimManager, we have the framework that supports the ability to do everything from manual interaction right the way through to semi-automated or fully automated activities connected through into your infrastructure using tools that are familiar to you, not necessarily just tools that are from MSC. If you want to then extend things through to, I guess, the nth degree of providing a very nice, simple interface to your end user communities, we have what we call our Flex UI. Now, the Flex UI is basically designed to provide an environment where you can provide an interface to non-expert users, but behind the scenes actually perform some very complex analyses. So this is where, if you want to provide, it's almost sort of a wizard-driven activity where what you're doing is to provide an interface where you're presenting information or options to users in language that's specific to them. You know, it's built on the domain that they typically work in. It's using terminology that's familiar to them, you know, rather than working on the standard SimManager UI, where you're going to have labels and menus that are familiar to, you know, or typical of the application, but not necessarily typical for the end user themselves. So we can extend things quite significantly to be able to provide custom UIs that are specific to the domain of that particular user. And you might have multiple user interfaces depending on the domain experience. So you may have one interface for novice users and a completely different interface for advanced users. But this again is an interface and a capability which is available out of the box with the Flex UI components that allow you to be able to potentially go all the way to something like this that you see on the right hand side, or maybe just work on small changes to the standard UI that you have within SimManager. Now, let's cut to a slightly different view on process, which is now starting to look a little bit on automate, if you like, sort of guided workflows. That's probably the best way to put it. Process templates, guided workflows, or what we call work requests. Okay, so the work requests are really an environment where you can build templates based on specific knowledge. So you might have a number of configurators within your company that would define the specific templates or workflows that should be followed by individual users. So you can see in the bottom left an example of the view of the templated approach, where you can visualize the workflow that will be executed, where each box is a specific step or a specific task in this individual workflow. And there could be connectivity between each of these tasks that you're saying, well, let's take the output from task number 1 and provide it as the input to task number 2. You may have some things pre-configured. So for example, you might have a specific task where you want to pre-configure the application that will be run with that specific task. Okay, so that's, if you like, enabling a guided workflow to be executed. In terms of the presentation of that to the end user, this is the typical view that they see. And again, this is something that can be reconfigured. You can lay out this interface slightly differently to be able to show certain information that's relevant to the user as the process is being executed. And you'll see an example of that as we move forward. But the key part for the user executing this process is that the individual tasks are available as buttons down the left-hand side. So this is a sequence of operations that they will follow, some of which have dependencies on others. So you'll see the run simulation box is grayed out because it's dependent on something else above that. And until those previous steps are complete, you can't execute the fourth one. From a project management perspective, it's quite a nice scenario in that you're able to get a project or a work request overview at a project level. So you can see the status of activity on each of those work requests at a glance at a project level. So you can get a very clear indication of, is everything green in this particular process? Has work actually started? Or is there some work that's maybe started, maybe completed, in fact, but it's red or it's yellow, indicating that there's something which is of concern that needs to be investigated, and we need to do a more in-depth view of what's actually happening. Okay, so how do we actually execute this process as a user? So in this instance, what we're working with is an aerospace example. So in this case, we've got various aircraft components that have been already populated into the database. So they may be individual monitor points, it might be loads, it might be mesh models, it may be a whole series of different aspects, might be material models. And you can see that as a user, I can go and browse through the content that we have available and go and interrogate different parts of the structure and see, does everything look like it's as it should be? And can I review everything in that interface before I actually start the work? So in this case, this next step is to say, from our parent project, let's launch the work request, where this work request focuses on building a full aircraft assembly. All of the models already exist, so we don't have to do any building. That's assumed to have been done by this stage in this particular workflow. But we're going to now start a work request to build this assembly. So at the top level, we give it the name. We can optionally give it a start and finish date if we want. And now we can then say, okay, let's launch this work request, which has a series of tasks involved in it. And in this case, the first 3 tasks are to go and build sub work requests for the wing, for the fuselage, or for the empennage. Okay. So in this instance, this is the, if you like, the next stages that need to be executed for this particular user. Okay, so just to reiterate what we've got now a hierarchy of work requests within SimManager. Top level is the aircraft level, and then subset to that are the fuselage, wing, and empennage work requests themselves. So let's manually change the status of the work request to work in progress. This is one of the few times you'll see this being done manually. In a lot of other cases, you will see that the status of activities will be changed automatically depending on whether the process is finished or not and whether it's run completely or not. But in this instance, what we're going to do is to generate the work request for the wing, where you can see here the template is automatically created because that's defined in the parent work request template itself. Okay, so we're going to create a sub work request for the wing assembly, again, optionally defining a start and end date. And this now is published in the right-hand side. So I said you can configure this UI to present information relevant to you. So in this instance, you can see that we've reconfigured this UI to give us a summary of all of our sub work requests in the right-hand side of the parent work request. So if I now dive into the wing assembly work request, I can now go through the process of executing the actions in here. Phase one is, let's just go and select the submodels that need to be included in this particular wing. So in this case, we're filtering on the type of model we're looking at. We're filtering on the project in which this data may come from. And then we can say, well, let's select everything and go and launch this activity, where we can now pick the item invariant. You can see the status has been set automatically as being complete. We can create now the item invariant for the wing itself. So this is, if you like, the empty container into which the wing model will now go. And now we will launch the third process, which is creating the wing model itself. Now, a lot of these things, for example, in here, we've got the pre-selection of the application itself. So there may be tens of applications registered in SimManager, but the ability to pre-configure as a templated approach which application should be run really simplifies things for the end user themselves. And in here now you can see the status at the parent work request, or sorry, the status of the wing work request, the status of the activity itself, and a summary of the model. So you can see exactly and go and interrogate the data that has been generated as my assembled wing model. And we can then go and click this as a link to open up the single object display of that individual wing, where you can see my assembled model from the 17 or so components that are there. Now, for any of you who know anything about aircraft, you'll see that the ailerons are in completely the wrong position. The reason for this is that the coordinate frames that are used in the full aircraft assembly are going to be specific to the load case that is used. So in this instance, the coordinate frames for the positioning of the ailerons in the wing are not included in the wing structure. So everything is set at the nose of the aircraft. But you will then notice whenever we assemble the full aircraft, those ailerons are moved to the right position relative to the wing. And then they will be oriented, so whether they're flap up or flap down, depending on whether it's a left or a right roll case for this particular aircraft model. So we'll see that as we go through. This is particular to the way in which this assembly has been done. So something might be different for each of the use cases that you have. Maybe you have analysis models which don't have any movable components. So rather than walking through this one by one, we'll just say, okay, I've walked you through the wing process, the fuselage process. Let's assume it's now done. Okay, let's then assume that the empennage is now done. So effectively, we've got to a case where, as you can see in the top right, the empennage models exist, the fuselage subassemblies exist, the wing subassemblies exist. So we can tick off each of those three work requests as being complete. And now we can go back to our top level aircraft assembly process, where now we want to be able to go through and actually run the analysis of the full, or run the assembly of the full aircraft itself. Okay, so in this case, top three stages are complete. We now want to run the fourth stage, which is to create the item invariant for the aircraft, and then launch the simulation generator for this case. So this is, if you like, the simulation generator is our matrix view to build assemblies from the content that we have, the submodels that we have. And one thing to stress on the simulation generator, it doesn't come out so much on this particular view, is that you can have multi-level assemblies in here. Okay, so whilst we say that we're picking aircraft materials, case control, loads, monitors, materials, etc. from here, you could actually have an instance where you might have submodels to these as well. So you can have a multi-level hierarchy in that assembly structure. In this case, we're going to go through the process of selecting one of the analysis types, so just the left banking case, and submit that job. In the previous simple example, I submitted all three simultaneously. I could submit all from here as well, but in this case, we're just going to run through the process on submitting one of those three. And then from here, you can see that this is our input deck, which is now created. You can see the ailerons are in the right position. And if we zoom in, you can see that they're angled either to a flap up or flap down case, depending on whether it's a banking left or banking right use case that we're actually working with. So there's a correlation between, you know, the positions of control surfaces, correlating that with loads, and also then the subassemblies for the submodels themselves. Okay. And as you would expect, as we had previously, for any of these individual items, you can see all of the components, you can see all of the audit trail that we have in there, and you can see all of the information for each of the models of interest. Okay. Having run this analysis once, you can now see that every one of my components on the left-hand side is now grayed out. And that's simply because having run one assembly, we of course can't change any of the inputs. Those are now frozen, but we can now go through the process of running the other analyses of interest. But in this instance, you can choose whatever approach you like on that particular analysis environment. If you want to create a new variant, we can then say, well, let's take this assembly as a, if you like, a baseline for the initial analysis. And then if, let's say, your loads have changed, or maybe you want to look at a new wing structure slotted into that particular assembly, you can create a new subvariant of that and then reanalyze that particular process to go from there. Okay, so that's the, if you like, the summary of the topics that we had for today's primary session. What I wanted to do then was probably, I was expecting to take a little bit longer to get to this point. I think what I can either do is to take some questions now, or I can go through a little bit more detail on some other aspects of the integration of processes themselves and look at a couple of others, whatever's preferable. Melissa, any suggestions, any questions coming in so far?
Yeah, I've got a question here. When using work requests, is there a sort of notification system? So can particular parts be assigned to a particular user, and can users be notified when the status of a task changes?
Yes, so that's a good point. It's something I missed whilst I was racing through the examples. In the work request integration, absolutely. One of the key things that we have with the work request implementation is the ability to assign a work request to a specific user. They will then get an email notification that something has been assigned to them, or similarly, they can have an environment where from their landing page, whenever they log in, they can see a summary of all of the work requests that have been assigned to them. Similarly, you can see any instance of work requests that have been created. So even though you might not be the user to whom a work request has been assigned, you maybe want notification that a work request is complete as well. And you can see all that information in there. Yeah, good point.
Yeah, that's nice. So you can use it as sort of a planning for yourself as well to organize not only for the organization, but organize it for yourself as well.
Exactly that. Yeah.
Let me check.
So whilst you're checking that, let me touch a little bit on the enrichment side, just to go through that in a little bit more detail. So I talked about the idea of enrichment really being a process that says, for example, if I import an input deck for a particular model, I can automatically enrich that to extract certain data from it. Now, it's important at this point to stress that the tools that you integrate with enrichment really are very, very open. So whilst the example I showed really was focused on the idea of saying, from this input deck that we have, let's generate a VCLAB representation of that particular model. So you can see this three-dimensional view that I can rotate and interrogate and have a look at. But it might be something quite different. So it might be just extracting some summary information about that model. So for example, for an input deck, how many loads, elements, and load cases have I got in this particular model of interest? Or maybe, and this is something that's quite often used in a multidisciplinary environment, is this idea of saying, well, if I've run let's say a thermal analysis for a particular model, I get a temperature distribution out of that thermal analysis. But often I want to be able to take that temperature distribution and then convert that into a set of temperature loads that can be applied to a structural model. Okay, so that's one example of the sort of connectivity between different disciplines and different items. And that is something that if you've got a script to do it, we can then launch that script in batch automatically as soon as the result of the thermal analysis is done. We can then automatically launch the process of generating the data for the downstream structural analysis moving forward from there. We've got a lot of customers who use that particular approach, especially where reformatting of data is important, because fundamentally it's an overhead that needs to be done. It's just an administrative task that needs to be done. And ultimately, if I'm, let's say, the person who's first in the chain, I'll just create results that are important for me. I will never create results and then convert them into the format for the next person in line. So it's always an overhead for the next person whenever they start to do whatever they need to do. if you can integrate that automation of the conversion as part of the process within SimManager, then it takes away some of that extra administration. It takes away some of that extra overhead that you have moving forward. Okay, so that's an important part to refer to. So from within the SimManager environment, what you've basically got is from within SimManager, you have the maintenance or the management of the files themselves on the server, but you may do the generation of the enriched data on a separate system, a batch system. It may even be queued through the HPC environment you have to be able to ensure that there's appropriate sort of scheduling and hierarchy of doing the enrichment, so that you don't stop doing an analysis simply to create a sort of an extraction of key results or key parameters for an input deck. That's something which is managed in the appropriate hierarchy, so the analysis jobs are run first, and the nice cosmetic stuff is done after that. One other aspect is potentially related to approvals. So within SimManager, there is an inbuilt approval facility. So if you've got data that needs to be approved prior to being released or promoted, you can set up an approval workflow within SimManager very, very easily, where you can have a series of different gates. So for example, for a particular workflow that or approval workflow that you have in SimManager, this could change dependent on projects as well. So you maybe have one approval workflow for models. You've maybe got a supplementary approval workflow for loads and a third approval workflow for materials, where you would have different people executing each of those workflows, or different people in the approval loop for each of those flows. So in this instance, you can have multiple steps. So in this case, approval step number 1 involves a combination of some approvers or an approver Molly manager who is mandatory. So she must say yes or no to a particular set of data that's coming in. But then there are optional approvers that could be added to that. So within the approval workflow, we can say that even though Molly manager is mandatory, we could have potentially either David or Andrew saying yes to a particular environment, and then that in combination with the mandatory approver saying yes takes that data item to the next level down, where the administrator might then have a supplementary review of that data, possibly with an optional approver in there. And at any point, you can see the status of the approval workflow for any data item in the system. So you can see if something has been waiting for approval for a period of time, you can then go and chivvy along the particular people who might be required to be able to release that to the next level. So that approval workflow often is used hand in hand with the release levels, which we discussed in the previous session. Release levels really being focused on the access control or the access levels for any data item within SimManager. So the idea being at release level 0, if I create data release level 0, it's probably only visible to me and maybe to my manager. But if I want to then expose it out to a broader user community, I need to promote it to release level 1, which means maybe it's exposed out to different people in my work group, maybe in the discipline in which I work, or maybe the particular group within the project that I'm working in. And then ultimately at release level 2 or above, then you're looking at that data which is then frozen and is released out to the overall project that any user can see it, whether they're a designer, stress engineer, thermal, whatever, structural, etc. Okay, so that's areas in which both the release levels and the approvals go very much hand in hand. The final part is maybe looking at solver integration options and trying to understand a little bit about, well, what are the key benefits of integrating solvers in different ways within SimManager? So there's lots of different configurations in here. And I guess some of this starts initially looking at, what a lot of people probably have today, which is an environment where you've got input decks on your local desktop. And if you want to submit them to an analysis environment, you need to copy them from your client machine over to the HPC environment, in whatever way, FTPing them over, whatever else. You've possibly got a Windows system here and a Linux system over here. So you copy it over, you remote log into the HPC environment, you submit the job as a solve, the results output comes back, and you can then recover that results data back into the client side by copying it back across the network to get your results, where you're now up to sort of 2 gigabytes of data or more moving across the network. And then on a local level, you'll post-process that to get a set of data, which you then want to share via email or other tools to other people in the team. The idea then, ultimately, if you want to archive that data, well, you can take that information and you can then import that manually into SimManager. So you've got a reference of the input deck, the result, and the key result values all within SimManager. So you've got that container of all that information available. The next stage to that is to say, okay, well, let's now work on the next phase, which is the import or the linking of SimManager and your HPC environment. So in this case, this is like the import and simulate process we started with today. The idea of saying, well, from the client side, we've done our model building in my preprocessor to generate an input deck, and then I'll take that input deck and launch the process of input and simulate from SimManager, which then says, well, let's rely on SimManager connecting to my HPC environment, where we can do the solve and then automatically collect the result back from the HPC into SimManager. So most of that activity is moving data between SimManager and the HPC, but there's a potential to do some post-processing. And in this instance, as a first phase, that might be done on the client side. So you need to move the results files out, do the post-processing, and then import the key results values, curves, etc., back into SimManager. The next logical stage from that is to do, if we like, more of a back-end assembly process. So this is our assemble and simulate activity, where we assume that all of our assembly is already in SimManager. And maybe for a particular car example, all we want to do is to change a model for the door structure and see, well, if I modify my reinforcing structure in the door and import that into SimManager, what would the effect be, let's say, in a crash analysis I do? Let's compare the baseline versus my new assembly with my new door put in. So the only thing that moves from the client to the server is that one door model. And then from that point, we can submit the analysis where all of the assembly is done at the back end to create the input deck. That is automatically recovered back into SimManager. The solve is then done as soon as the input deck exists, and that result data can go back into SimManager if necessary. And then we might also have some sort of compression utility to be able to reduce the file size on that, and then we'll store the compressed result back into SimManager. And then the final stage would be to do some post-processing in batch in SimManager. So the only thing coming back at the end of the day are images, curves, and movies. So if I look at the boundary between the client and the SimManager server, there's a very small amount of data moving left to right, where only the submodel for the door moves initially, and the only thing that comes back are the summary information for the images, movies, curves, etc., that summarize the result for the analysis that has been done. So it allows me to very, very easily just move small amounts of data to be able to review the comparison between different analysis decks, between different configurations moving forward. But all of the hard work is done at the back end, with all of the data being automatically managed in SimManager from the process being executed, controlled by SimManager, but executed on your HPC. So I think that probably brings me to the end of what I wanted to get through today. I appreciate it was a very quick summary through a lot of capability in SimManager, touching on analysis integration, touching on preprocessor integration, touching on the REST API, touching on workflows, touching on approvals. So I hope there was a lot out of that was, some of it was relevant. I doubt that all of it was relevant to everybody, but by all means, if you have any supplementary questions or any additional information that you need, please feel free to get in contact and we can try and fill in the gaps and help you understand where to go from here.
Yeah, definitely. Yeah, very clear. And indeed, it is going to need, it's going to be a custom for everyone, specific scenarios. So definitely, like as Keith said, if you would like to plan a separate session, because now we've got some ideas on how to work with this. But if you have some ideas on how to implement it for your specific company or your specific work, then definitely contact us, and we can host or plan a session one-on-one with Keith or with us. There's one more question that came in. Can you create stress dossiers, certification documents as outputs from SimManager? So is there a default format for this, or is it user dependent?
So often it's going to be user dependent. So we don't. So the stress dossier ultimately, I guess you're probably looking at a couple of stages slightly further downstream of what I've shown today. Where what I've shown in this example is, okay, we've got the initial phase of let's set up the analyses for all of the different configurations. For the, in my case, the aircraft, we've got lots of configurations of loads and whether we've got stores on the wings or not, or what the deployment is for movable surfaces, etc., etc. Out of that, you get your, if you like, your analysis results, which are the starting point to generate the internal loads on structures. And then from there, you're looking to do some downstream analysis to do, the detailed check on individual components to generate the reserve factors for an aircraft. Is it, are we looking at things which have got a serious risk or not? And then from there, building a stress dossier. So the work requests that we have, not the work requests, sorry, the report templates that we have will help you go some way to that. But it's probably worth having a look at the specific use cases that we've got. Often what we've done in the past is to work with specific customers to build an integration with their existing environments. So yes, we can have the management of the individual components that can be used to build the content of a stress dossier, but ultimately that's going to be the starting template from which there'll be lots of comments and lots of descriptions that will be added to that to qualify certain pieces of information at certain levels. So I would say that what I've shown you is, if you like, it's sort of the top end to the process. We need to then have a discussion about what is available and what's required for the next half of the process, which is the more detailed sort of hand calc question to generate the stress dossier from there. But certainly the extraction of images and the extraction of views and things like that can certainly be used in the report templating environment to build the initial framework of a stress dossier that can be revised over time and extended to include all of the extra pieces which you'd need to add. That's a long answer to a very short question, but hopefully it covered the answer.
Sufficient, yeah. I think so, yes. Let me see. I think there's a couple questions similar to what we went over last time. So, for example, what could be a good starting point for a company to start considering SPDM? I think that's still, I would say
that for probably, depending on whether it's data or whether it's process driven, I would say that probably moving from this slide to something which is much more focused on this kind of environment is a great starting point. Okay, so often the initial low-hanging fruit, and this is customer by customer, there's often different drivers as to why you implement SimManager. For some customers, it's very much on getting data under control, providing a better means to share analysis data. That's a key thing for them. So in that instance, it's a data-focused driver initially. But in this case, maybe connections through to the HPC are important. I sometimes kind of lose track of the fact that lots of customers have this sort of frustration of just doing something simple like submitting a job involves lots of copying of files and moving of files and logging into different systems. Actually, just having SimManager in place to act as a job submission environment makes their life a lot easier. And the automated recovery of results makes life a lot easier for them as well. So you've got a very clear picture of what analysis results have been generated from what input decks. Whereas if you just look on a file system, it's just a collection of files, and you're trying to rely on names and dates and times to be able to try and understand what inputs generated what outputs, and it's sometimes not always that straightforward to do. So in some instances, this kind of environment, that import and simulate configuration, is often a good first stage for a lot of people. But as I say, maybe it's a little bit more specific on data sharing between different groups, in which case file conversion, standardizing the availability of scripts across an organization is often good. So rather than having everybody with their own version of a specific script sitting on their desktop, well, if we've got everything contained in SimManager and there is one script that has been approved and is released to all the end users, then you're sure that you're running everything in a consistent way, irrespective of where you sit. But that's kind of the point where it's usually a discussion between us and the customer of interest to be able to see, okay, where is what's the need, what's the fit, what points do we put in place, and where do we go?
I guess following up on that question, I've got I think a last one for now. Post-processing and automation of post-processing of results. Would SimManager be a suitable solution to this problem? So speed up post-processing of results. And then I think it ties in with that as well. Is SimManager also suitable for a smaller team, so 2 to 3 people, or do you recommend it only for a larger team?
No, yeah. So I'll answer the second one first, because it's an easier answer to say. Well, 2, 3, 4, that's fine. I mean, I would say, the way the licensing is configured as well now, actually financially it's viable for small teams as well. So we've configured the licensing system in such a way that actually, there isn't a prohibitive license cost to simply install SimManager and get it running. So I would say yes, 2, 3, 4, 5 people. That's kind of that's certainly a feasible group, and certainly within even larger organizations, often we work with smaller teams where you're actually dealing with 4 or 5 people as a team in the individual organization, and we're trying to provide benefit for that small team initially. Coming back to the question on post-processing and automated post-processing, it's important to make the point that SimManager itself does not do any post-processing at all. No post-processing is done in SimManager, okay? So that post-processing capability is something that SimManager launches, but is done by a third-party tool, okay? So that third-party tool might be Patran. So the example I showed earlier, I was running Patran in batch. So in that instance, if I ran Sol 101, I generated images and individual values. So I've got some PCL scripts to be able to go through that whole process. When I ran Sol 103, I generated some movies automatically. And whenever I ran Sol 109, I didn't run Patran at all. In that case, I executed some Python scripts to be able to strip through an F06 file and generate some curves out of the dynamic response at specific nodes within that solution sequence. So what you've got to think of is what SimManager controls, or what SimManager defines, is this scenario that will be run. And within that scenario for post-processing, you can then link in other applications to do the post-processing. So you may have, in this instance, post-processing tasks that run a run a post-processor, or they may run some of your in-house Python scripts or something like that. Okay, but fundamentally what you're trying to do is to create either images, curves, or movies from a set of results that are generated as a result of the solve process. SimManager is the environment that controls and manages the launching of that post-processing activity, but the post-processing itself is going to be an application external to SimManager. But fundamentally, we don't care what that is, as long as you can start that post-processing script really from a sort of a command line kind of activity, then we can launch that. The only thing that we do provide as part of the sort of delivery of SimManager as an optional component is the vCollab representation. So it is possible to generate a vCollab representation of the results files themselves, which is something that is able to be interrogated. You can manipulate it, you can section the results, you can have a look through different load cases and see the stresses or displacements on that lightweight view of that result file. So that's I guess the only other thing which is which is a little bit more delivered with the product. But the if you like, the automated post-processing, yes, it's executed from SimManager, but it's using tools that are external to SimManager.
I think that's very clear. At least I hope. Let's see, I think, yeah, clear. Thanks for formulating the question in a more presentable way. Good. I think there's more questions, or people will probably come up with more questions as they let this sink in. So as posted and as said before, definitely contact us if you have any additional questions, or if you'd like to plan a session with Keith to go more into detail on what has been said today or what has been said last session. And I think Keith, thank you for today. I think you're available. Sorry, you're available for these kinds of sessions, right?
For sure, yes. I mean,
yeah.
By all means, I'm happy to have a follow-on discussion with anybody. I'll even talk a little bit slower, and we can go through things in a little bit detail. I'm conscious that today was very much focused on providing a light touch to a whole range of aspects centered around process. So we can start to have a more in-depth discussion about what might make sense for different people and help them move forward. Yeah,
so hopefully this is for you as an attendee also a sort of a starting point to on a journey to improve either your data management or your process management, and let's just stay in touch from here and see where this takes us. Practically speaking, I will send the recording of this webinar and the last one to everyone, so that should be later today. And yeah, as I said, any questions always welcome. And I think with that, we can end the session.
Okay, thanks very much.
Thank you very much. And everyone stay safe and healthy. And hopefully till next time.